Hello viewers, welcome to my channel. I'm Hasham Ali Khan. So now I'm continuing the problem on set theory. Last video I have completed 4 problems. Now I'm continuing the 5th problem. So before watching this video, I suggest you to first watch the introduction part. The theory of first video, second video are very important. If you join now, you may not be able to understand. So if you want the complete command on the topic of set theory, first of all, you must know the meaning, the elements, the set operations, all these things. If you know, then only you can be able to understand. So if you have not watched the earlier videos, I suggest you to go to the playlist of my channel. Select the topic Business Statistics 2. In that Business Statistics 2, you select the topic set theory. Watch the first theory video, second theory video, then first problems. You will get the grip on the problem. Then you can be able to understand. Now I'm continuing the 5th problem. But before starting the problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. So take a printout and keep it ready. Now 5th problem I am reading out. Which of the following sets are finite? It's just a theoretical question. Some 4 bits are given, A, B, C, D. We have to decide which set is finite, which is infinite. What do you mean by finite set? A set which have limited number of objects or limited elements. Countable, limited number of elements, it's called a finite set. If we have unlimited, there is no limit on the elements of the set, we call it as infinite set. So now one by one I'll read out and we'll decide whether it is a finite set or infinite. First one, A bit. The set of days in a week. The set of days in a week. We already know the days of the week. 7 days are there in a week. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So totally 7 days. We don't have 8, 9 days. We don't have unlimited number. We have limited 7 days of the week. So we can say it is a finite set. First A bit, it is a finite set. So here there are only 7 days in a week. So the set is a finite one. Completed. Now B bit. The set of odd natural numbers. The set of odd natural numbers. The odd natural numbers are 1, 3, 5, 7, 9, 11, etc. up to unlimited. There is no limit of odd number of odd numbers. It can go up to infinity. So the set of odd number is an infinite set. The set is 1, 3, 5, 9, 5, 7, 9, 11, 13 like that. It goes on. So it is an infinite set. Next one, S is equal to, S is a set which consists of X as an element such that X is equal to 2n and n does not belong to natural number. N does not belong to natural number. So when n does not belong to natural number, n numbers are infinite numbers. So 2n also will become infinite. So the given set S is equal to X such that X is equal to 2n is an infinite set. Since n does not belong to natural number, which is an infinite set, hence set consists of 2n is also infinite. Next, the 4th one, X, capital X is the set name. The set consists of small x element such that X is a vowel. So in English language, the vowels are A, E, I, O, U. These 5 alphabets are called vowels. So only 5 vowels we have: A, E, I, O, U. X is equal to X such that X is a vowel. Since vowels are the alphabets A, E, I, O, U, only 5 alphabets. That's it, not more than that. So it's a finite set. Then the set is X is equal to A, E, I, O, U, which is a finite set. That's it. This is the end of problem number 5. Now I am reading out problem number 6. Now carefully you see, given a set A is equal to, so we are given the set elements of A 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So from 6 to 16 are the elements of the set A. Name the subset that satisfy the condition stated below. Subset means a set which is derived from the main set A. A set which is derived from this main set A is called subset. So we have to form the subset according to some conditions. What are the conditions? First one, A. The subset contain all even numbers. Even numbers are 2, 4, 6, 8, 10, 12, 14, like that. Any number which is divisible by 2 is an even number. Even numbers are those numbers which are divisible by 2. The set is 6, 8, 10, 12, 14, 16 because we are given the numbers from 6 to 16. From 6 to 16. This is the universal set. From this set we are deriving a set which consists of even number. So 6 is an even number. After 6, 8 is an even number. 10, 12, 14, 16. So these are the even numbers. 6, 8, 10, 12, 14, 16. These are the even numbers. So this is a subset derived from the set given A. These are the even numbers. Next, B question. The subset containing all odd numbers greater than 8. Odd numbers. Odd number here are 7, 9, 11, 13, 15. These are the odd numbers. But odd number should be greater than 8, it is saying. Greater than 8. So after 8, 9 is the odd number. 9, 11, 13, 15. 9, 11, 13, 15. These are the odd numbers which are greater than 8. So here odd numbers are not divisible by 2. Any number which is not divisible by 2 is an odd number. The number greater than 8 but not divisible by 2 are the number which are greater than 8 but not divisible by 2. That means it's an odd number. So what are the odd number above 8? 9, 11, 13, 15. This is the subset which consists of odd numbers greater than 8. Last, C bit. The subset containing all numbers divisible by 3. So which are the numbers which are divisible by 3 from that? 6 is divisible by 3. Yes. Then 9 is divisible by 3. Yes. Then 15. 12. 12 is divisible by 3. 3 4s are 12. And 15 is divisible by 3. So how many numbers are divisible by 3? 6 is divisible by 3. 9 is divisible by 3. 12 is divisible by 3. 15 is divisible by 3. So these are the numbers which are divisible by 3 from the given set. The given set is A is equal to. From this given set, we can derive a subset which consists of numbers divisible by 3. 6, 9, 12, 15. That's it. Or problem number 6 completed. Now, 7th problem. How many subsets can be derived, can be formed from a set A? That means power set we have to find out. How many subsets can be formed from set A? 6, 9, 12. List them. So 3 elements are there. 6, 9, 12. These 3 elements are there in a set A. So how many subsets we can form from this main set? The power set. The power set is 2 to the power of n. So how many elements are there here? 3 elements are there. So 2 to the power of 3. 2 2s are 4, 4 2s are 8. That means 8 subsets we can form from the given set. A is equal to 6, 9, 12. A is equal to 6, 9, 12. The total number of sets that can be formed from the above set are 2 to the power of 3 because 3 elements are. So 2 to the power of 3, 2 2s are 4, 4 2s are 8. So we can form 8 subsets from this set. So what are the 8 subsets? Now list them. It is asking you to list them. First set is a null set. Null set means a set which does not contain any element. Empty set. So we'll begin with empty set. The sets that can be formed from are, first of all, empty set. Remember, empty set is also one of the set. Empty set is also one of the set which does not contain any element. 1. Then one set will contain a number 6. Because 6 is an element. So we can make a set containing only 6. So 6. Then one subset we can make by taking the element 9. One subset we can take by taking the element 12. The first nil, that is null set. Second set only 6, one element. Third, next set only one element 9. Then next set only one element 12. Now we take the combination. First we take the combination 6 and 9. We take a set consist of two elements 6 and 9. 6 and 9. Next element will take 6 and 12. First we have taken 6 and 9. Next we can take 6 and 12. So 6 and 9, then 6 and 12, and 9 and 12 also. 6 and 9 one set, 6 and 12 another set, 9 and 12 another set. So 6, 9, 9, 12, 6, 12. Last one, all the three. 6, 9, 12. This is also one of the subset. So totally 8 subsets we can form. Now check. 1, 2, 3, 4, 5, 6, 7, 8. So totally 8 subsets we can form from this set. A is equal to 6, 9, 12. It is called power set. 2 to the power of n. 2 to the power of 3. 8. So 8 sets. Again I repeat. First, null. No element. One set. Pahla set. No element at all. Now we take one single digit. Single element. 6 is one set. 9 is one set. 12 is another set. Now we take the combination of 2's. 6 and 9 one set. 6 and 12 another set. 9 and 12 another set. Lastly we take all the three. 6, 9, 12. Over. You count 8 sets. 8 subsets we have formed. Now, 8th problem. Name the subsets of the set X. Now in the problem, a set is given, set X. So what are the elements of this set X? Circle, triangle, square. So 3 elements are given in the set X. Now we have to form subsets. So how many subsets we can make from this main set? Exactly similar to the previous problem. Previous problem we are given numbers. Elements are given numbers. Here elements are not given, words are given. Circle, triangle, square. Exactly same way power set. 2 to the power of 3. Because 3 elements are there. So 2 to the power of 3. 2 2s are 4, 4 2s are 8. So 8 subsets we can form. How the 8 subsets here? The total number of sets that can be formed from the above set is 2 to the power of 3, 8. 8 subsets. First subset, null. Null means no element at all. First subset. Now we take individually. We'll make a set individually. First set circle, second set triangle, third set square. Individually we have taken. Now we'll take the combination of 2's. Circle and triangle. One set. Circle and triangle. Second we'll take triangle and square. So triangle and square another set. Next we take circle and square. Circle and square. Last all the three circle, triangle, square. All the three. Now you count the number of subsets. 1, 2, 3, 4, 5, 6, 7, 8. So totally 8 subsets we can form from this X set. Now 9th problem. Given X is equal to 1, 2, 3, 4. Write the power set. Exactly similar. Previous 3 elements are there. Now we have 4 elements. What are the 4 elements? 1, 2, 3, 4. That means 2 to the power of 4. 2 to the power of 4. 2 2s are 4, 4 2s are 8, 8 2s are 16. So totally 16 subsets we can make from the given set, power set. 2 to the power of n. 2 to the power of 4. Right? Now, see, X is equal to 1, 2, 3, 4. 4 elements are there. Now, the total number of sets that can be formed from the above set is 2 to the power of 4, 16. Previous problem, 3 elements are there. Now we have 4 elements. Now, the power set of X is, now first of all, null. As usual, empty set, null set. Now, individually we take subset individual element. So 1 first, then 2, 3, 4. Individually we have taken a subset. One element we have taken. One element we have taken. 1, 2, 3, 4. Now we take the combination. Combination of 2's. then combination of 3's, then combination of 4, right? Combination of 2's. What are the 2's combination? 1 and 2 is set. Then 1 and 3 is another set. Then 1 and 4 is another set. So 1 and 2, 1 and 3, 1 and 4, right? Now we take 2 and 3, another 2 and 3, one set, 2 and 4, another set, 3 and 4, another set. 2, 3, 2, 4, 3, 4. 2 digits over. 2 elements over. Now we take the 3 elements. 1, 2, 3. 1, 2, 3, one set. Then 1, 2, 4, another set. 1, 2, 3, 1, 2, 4. Next, another one will take 2, 3, 4. 2, 3, 4. Then 1, 3, 4. 1, 3, 4 over. The combination of 3 elements over. Now lastly, combination of 4 elements. The combination of 4 elements, 1, 2, 3, 4. 1, 2, 3, 4. Now you count it, you will get 16 subsets. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's it. So we have formed 16 subsets from the given set x is equal to 1, 2, 3, 4. That's it. So now problem number 10. See the 10th problem. This is the last and final problem of exercise 1A. 10th problem. Which of the following sets are equivalent? Are they equal? So we are given one A, B, C, D, E. 5 questions are given. In each question we have to decide whether the sets are equal sets or equivalent sets. Whether the sets given in the problem are equivalent and equal. Both we have to check. Right? So equal, first of all, definition of equivalent set and equal set you must remember. Equivalent set means two sets are said to be equivalent if the number of elements of A set and number of elements of B set both are equal. If the number of elements of A set and number of elements of B set both are equal, then we can say equivalent set. Then what is equal set? Equal set is that set where the elements of A set are exactly same as elements of B set, and elements of B set are exactly same as element of A set. Then both the sets we can call it as equal sets. That's it. So we will apply this rule to find out A, B, C, D, E. First one, A bit. See A bit. A is equal to, A is the set, is equal to, elements are 1, 2, 3, 5, 7, 11, 13, 17, 19. These are the elements of A set. And B set 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. So we are given a number of elements in A set, a number of elements in B set. Now we have to decide whether this A and B are equivalent, equal or not. Both are equivalent or not, both are equal or not. Now see, A is equal to 1, 2, 3, 5, 7, 11, 13, 17, 19. These are the elements given. B is equal to 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. First we count how many elements are there in A and B. A, NA is equal to 9. NA stands for number of elements in the set A. NA is the notation which is given. NA is equal to number of elements in set A. So 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 elements are there. NB is equal to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means A set is having 9 elements. B set we are having 10 elements. Elements are not equal. So we can say A and B are not equivalent. A and B are not equivalent. The sets are not equivalent as the number of elements are not equal, not same. Then we'll check whether it is equal or not. Equal means same elements should be there in A and B. But it is not same, no? Here 1, 2, 3. Here 1, 3, 5. 2 is not here. 2 element is there in A set, but 2 element is not there in B set. Similarly 19, 17, 13. 13 is there. 15 is not there. In A set, 15 element is not there, but here 15 element is there. That means we can say all the elements of A and B are not exactly same, different. So both are not equal. The set A and set B are not equal. The sets are not equal as every element of A is an every A is an element of B are not equal as every element of A is element of B. Both elements are not exactly same. If both the elements are exactly same, we can say equal. That's it. Now third one. Second question, B bit. X is equal to set of natural numbers between 2 and 9. Here the set is given set builder. Rule method. What is the rule? X is equal to set of natural numbers. Natural numbers are 1, 2, 3, 4 like that. Between 2 and 9. Between 2 and 9 means 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. These are the numbers which are between 2 and 9. And y is equal to 3, 4, 5, 6, 7, 8. Y is another set whose elements are given 3, 4, 5, 6, 7, 8. So we can write it here. X is equal to set of natural numbers between 2 and 9. So between 2 and 9 the numbers false are 3, 4, 5, 6, 7, 8. And y is another set whose values are given as 3, 4, 5, 6, 7, 8. Now nx is equal to 6, ny is equal to 6. nx का मतलब number of elements in x set. ny means number of elements in y set. So we can see here 6 elements are there in x set and 6 elements in y set. When both the sets are having same number of elements, the sets are called equivalent sets. Equivalent sets. Now we have to check whether it is equal or not. Yes, both x and y are equal sets also because the elements are exactly same. The elements of x set and elements of y set exactly same. There is no difference at all. So we can say both the sets are equivalent and both the sets are equal. As every element of x is the element of y, so the sets are equal. X is equal to y. Now C bit. P is equal to x. P is a set. Consists of x and element. X plus 7 is equal to 10. X plus 7 is equal to 10. That means if we take x is equal to 3, then 3 plus 7 is equal to 10. So we can write x is equal to 3. X is equal to 3, only one element. And q is equal to x such that x square minus 9 is equal to 0. Two sets are given, but the sets are not a roster model, not a tabulation model. The sets are given in set builder form, rule method. So by applying the rule, we have to see, we have to check both the sets. First p x, x such that here p is equal to x such that x plus 7 is equal to 10. Q is equal to x such that x square minus 9 is equal to 0. These are the two sets given in the problem. Now, in set P, if x is equal to 3, then 3 plus 7 is equal to 10. In this P set, if we substitute 3 in place of x, it will become 10. That means P3. P is the set. X is 3. So NP is equal to 1. That means only one element is there in P set. In P set, there is only one element. What is that element? 3. Because when we put 3, n plus 3 is equal to 10. 3 plus 7 is equal to 10. Right? So P of 3, that means the element is 3. This is NP1. Q is equal to 3 minus 3 because x square minus 9. So when x square minus 9 is equal to 0, if you take plus 3. If you take 3 here, 3 square, 3 3 is a 9, minus 9 is equal to 0. 3 square means 3 into 3. 3 3 is a 9. 9 minus 9 is equal to 0. First, suppose if we take x is equal to minus 3, then also it will become 0. How? Minus 3 square. Minus 3 square. So minus into minus will become plus. Plus 9. Plus 9 minus 9 will be 0. That means the condition is satisfied x square minus 9 if we take plus 3 or if we take minus 3. If we take plus 3, condition is satisfied. If we take minus 3, condition is satisfied because minus 3 square, minus 3 whole square is equal to minus into minus plus 3 3 is a 9. Plus 9. plus 9 minus 9 will be 0. So the elements of this second Q is plus 3 minus 3. So NQ is equal to 2. That means the elements in Q set are 2 elements, whereas elements in P set only 1 element. So it is not equivalent. The set P and Q are not equivalent. As the number of elements in P is not equal to the number of elements of Q, P and Q are not equivalent. It is not equal. Now we have to check, is it equal or not? No, it is not equal. P and Q are not equal because the same elements are not there in both the sets. In both the sets, same element is not there. In P set we are having only 3, whereas in Q set we are having 3 and minus 3. 3 and minus 3. So both the sets are not having the same element. So we can say both the sets are not equal. So every element of P is an element of Q, but every element of Q is not an element of P. The two sets are not equal. P is not equal to Q. So this is the end of C bit. Still D and E bits we have to do. Now see the D point. D point, C is equal to 752. 3 elements are there for the set C, 752. And D is equal to 257. Another set D is having 257. Now we have to decide both the sets are equivalent or not. Both the sets are equal or not. Right? So first C, 752 are the elements of C and 257 are the elements of D. So how many elements are there in C? 1, 2, 3. NC is equal to 3. How many elements in D? 1, 2, 3. And D is equal to 3. That means equal number of elements. In both the sets we have equal number of elements. When number of elements are equal, we can say both sets are equivalent. Both sets C and D are equivalent. As the number of elements in C is equal to the number of elements in D, so the sets are equivalent. C equivalent to D. Now we have to decide whether it is equal or not. When it will be equal? When the same elements are there in both the sets. Same elements should be there in both the sets. Then we can say it is a, the elements are equal, the sets are equal. Now you check. First C, 7. Is there any 7 here? Yes. 5. Is there any 5 here? Yes. 2. Is there any 2 here? Yes. That means the elements of C and D are exactly same. The elements are exactly same. When elements are same, both the sets are called equal sets. We can say C and D both are equal sets, as every element of set C is an element of set D and every element of set D is also an element of set C. So the two sets are equal. C is equal to D. That's it. So D point completed. Last and final point, E. M is equal to 8, 12, 4. 3 elements are given for the set M, and N is equal to, another set is there N. The elements are 6 minus 2, 2 cube, 5 into 2. These are the elements given in the second set N. So we'll write out M is equal to 8, 12, 4, whatever is given in the problem, 8, 12, 4. N is equal to 6 minus 2, 2 cube, 5 into 2. Whatever is given in the problem, same thing I have written. Now, so first n is equal to 8, 12, 4 as it is. Second, n is equal to 6 minus 2. You will get 4. 2 cube, 2 2s are 4, 4 2s are 8. 5 into 2 is 10. Now these two sets are there, M and N. So how many elements are there in M? 1, 2, 3 elements. So M is equal to 3. Similarly, how many elements are there in N set? N of N is equal to 3. That means equal number of elements. The number of elements are equal in both the sets. So we can say both the sets M and N are equivalent. As the number of elements in M is equal to the number of elements in N, so the sets M and N are equivalent. So M equivalent to N. Now we have to check whether it is they are equal or not. Both the sets are not equal, because every element of M should be the element of N, and every element of N should be the element of M. When both the sets are having the same elements, then we can say both the sets are equal. But here it is not. See here, the elements are 8. 8 is there. 12. Is there any 12 in the n set? No. 4 is there. Here 10 is there in the n set. Do we have 10 here? No. That means the elements are not same. So we can say both the sets are not equal. As every element of M is not an element of N, so the sets are not equal. M not equal to N. That's all. So we have completed 10 problems in exercise 1A. So after watching this 10 problems on set theory, I think you got the command. It's very simple, only logical thinking is required. Not much work is required, only logical thinking. So that's why again and again I am telling, don't ignore the theoretical part. If you have watched the theory videos and the first, second video, definitely you can enjoy the remaining videos. You can get a good grasp on the topic of set theory. Okay, we'll continue the next exercise 1B in the next video. So if you are satisfied with my lecture, give a like to the video. Share my channel in your group, in your friend circle, so that more students can watch the video and increase the knowledge. Give your comments on these lectures. And lastly, don't forget to subscribe my channel. The next problem, we'll do it in the next video.